followers and the teacher.
Notifications on and everything.
These are things I care about. Okay, so the second set of directions.
Whoa, that doesn't matter.
Okay, the second set are going to be factoring perfect square trinomial. So the first part was just finding the product, just reviewing foiling. We have literally done it like 5 times in this class. So the first part of this section was just reviewing foiling, distributing a binomial and a binomial. Now we're going to factor. So once again, anytime the directions say to factor, you want to write as multiplication. That's what factoring means. It is just rewriting a polynomial as something times something. So we are writing as a product. So you know you have factored it. Now you may have to factor it completely, but for the most part, you know it's pretty well factored if it's something times something. So what we're going to look at today is we are factoring perfect square trinomials. So if you look at the directions, perfect square, we talked about perfect squares on Friday. Perfect square would be what? 4, 9, 16. Perfect squares are numbers that I can square to get. So 2 squared is 4, so 4 is a perfect square. 6 squared is 36, so 36 is a perfect square. So we are looking for perfect square trinomial. We talked about a trinomial last unit. Trinomial has how many terms? 3. So we are factoring perfect square trinomials. So we are factoring a polynomial with 3 terms. Okay, so what is different? So what is different than what we did on Friday is we are doing a difference of 2 squares, like something squared minus something squared. Now we're talking about a trinomial, perfect square trinomial. This is kind of a shortcut. So what this shortcut is if the first, yes.
Can I get some of that filet?
What size?
Would you basically just do the same thing?
No, it's a little different. Here, okay, so couple things. Here's the formula, perfect square trinomial formula. Okay. Okay, here's the formula. Ax squared. Where exactly is that
Can
squared?
you just keep the middle term the same?
Yes, let me explain this.
I don't think you need to. I think we got it.
Yeah, let me explain this.
All right, well,
Guys in the front, I'm going to make it every other if we can't handle it. Please, just don't talk over me. Okay, so perfect square trinomial. As I look at perfect square trinomial, let me make sure I have that formula. The first and the last term have to be perfect squares. We're good. The first and the last term has to be perfect squares. And there's a 2 here. That's the only thing I made a mistake. So ax squared plus 2abx plus b squared. Okay. Let me explain what this means. This looks complicated. I get that. So what you're going to look at is the first and the last term. First of all, the first and the last term has to be perfect squares. So can I write the first and the last term as perfect squares? Okay, so let's think about it. We talked about some of this on Friday. So what squared will give me 4x squared? 2x. What squared gives you 1? 1. So first thing you need to check, your first and your last need to be perfect squares. Okay. After that, you need to make sure your middle term is equal to 2abx. What that means is this first part would be your a, and this last part would be your b. So what that means is you need to take what squared from the first term, and then what squared from the last term. So this is your a value, this is your b value. In order for this to work, you have to take, this has to be 2abx. So this has to be 2 times a times b. Does that give you 4x? 2 times 2x, 4x. The negative, it doesn't really matter where it's at. Okay?
Yes, it would.
Yes, so that would work. So when you write it, this is going to be 2x. Now this is where the negative comes into play. If this is a negative here, this has to be minus 2x minus 1 squared. Okay, now that's where the negative comes into play. If this is the minus right here, it has to be a 2x minus 1 squared. And that's the shortcut. So if you have this pattern, then this is the same as, so if you have that pattern, that's the same as ax, either plus or minus b squared. That's the shortcut. Now, what I've said up to this point is factoring is writing as something squared, or something times something. So this was factored, but is this written as something times something?
No. Yeah.
It's not, but what does squaring something mean? Multiplying it by itself. So that is the same thing as writing it times itself. So even though it's something squared, that is the same thing as writing it times itself. So either way you would write your final answer, I don't care. One of those two ways. You could just put it as squared because that means multiply by itself. Okay, these are kind of tricky. Let's look at a couple more examples. I think the more examples that we do, the better it'll be. Let's look at a couple more examples. If I have one like this. Let's look at one like this. So 4n squared plus 12n plus 9. So first thing I notice is a trinomial, and you want to notice, okay, is the first and the last terms, are the first and last terms perfect squared? Let's just see. Okay, something squared that will give me 4n squared, 2n. And then my last term, something squared that will give me 9, 3. Now in order to use this shortcut, in order to be able to just write it as a plus or minus b squared, you have to make sure the middle term is the same as 2ab, and then the x. So 2 times, what's a? 2n. That's the number value right here. So 2 times a, 2 times 2n, times, what's b? 3. And then you just put an x there. Does that give you the middle term? Does that give you 12? This will be n, actually, because we're dealing with n's. Does that give you 12n? Yes, I guess you don't need another n there. Sorry. You can just put the 12. The n comes from a. 2 times 2n times 3, 12n. So since that works, you can just take it as a plus b. So 2n plus 3 squared. That's it. No, you can write it times itself if you want to, but you don't need to, because that's what squaring means, is multiplying it by itself. Okay. Let's look at, let me do a couple more. These are kind of tricky. Let's look at example 3. If I look at example 3, let's try one like this. 25b squared plus 20b plus 4. Okay, 3 terms. First of all, is there a GCF? Always check for a GCF. I forget to do it. Is there a GCF for all 4 of these? No. 25, 20, and 4 don't share anything. I can't factor it out. Always check for that first. Now I see I have a trinomial, and you notice, oh, the first and the last are perfect squares. So what squared gives me 25b squared? 5b. What squared gives me 4? 2. So then we need to check, okay, is the middle term the same as 2ab? So 2 times a, what's a? 5b. Times b, which is 2. Does that give you back 20b? Yes. 2 times 5b times 2, 20b. So you need to make sure that you can use that your middle term is the same as 2ab. If it is, then your final answer is just going to be
5b plus 2 squared.
Yep. Since they're both positive, it's just 5b plus 2 squared.
Alright, do one where it doesn't work out.
Like, if you have one like this, we did this on Friday. If you have one like this, just do this real quick. Well, we'll do one next in this next section where they don't work out. If I have one like this, we did one like this on Thursday or on Friday. How's this one different? It's a binomial, not a trinomial. It's a binomial, so I want to check, is this a difference of perfect squares? Is this a difference of perfect squares? Is it a difference? Guys, pay attention. Is it a difference? Are we done, or? Well, I'm waiting, so. We good? We done?
We are now.
Okay, thanks.
Alright, you're welcome.
Okay, it's a difference because I'm subtracting. Are these perfect squares? So what squared gives me 16p squared?
8.
What squared, not times 2?
4.
4p. What squared gives me 1? 1. And if it's just a binomial and it's a difference of perfect squares, my answer is 4p minus 1? Nope, because it's not a trinomial. It's a difference of perfect squares. Go back and look at the notes from Friday. It was on page 50.
Oh, it's plus.
Yep, 4p plus 1. That's the difference from what we did Friday. Today, it is a trinomial. Friday, it was a difference of perfect squares, binomial. Okay, and that would be your answer.
Why did you just do a binomial?
Because I just wanted, because some of it, there was some on the homework, so I just wanted to review real quick. Okay, so real quick, if you're just started today, I'll have to get you the homework packet. Give me a second. Go ahead and get out the Unit 3 homework packet. Actually, there's none on the homework today, but that's okay. It doesn't hurt to review. 51 through 60 is what you can work on now. 51 through 60. So 51 through 60 is what you can work on. Huh?